So for here, the very first question, all you had to do was graph. Keep in mind that when you're graphing, if it is an open circle, it does not have the equal to line underneath it. So it can either be a greater than symbol or it could be a less than symbol. Those would have open circles. Remember that the arrow points in the direction that you're going to graph as long as you have your variable on the left side. If your variable is written on the right side, you need to reverse the entire inequality. So for example, if you see something that says 11 is greater than x, you do not want to graph it going to the right. You would want to rewrite this as x is less than 11, and it would be an open circle going to the left. Open at 11 goes to the left. You want to make sure that you rewrite them so that your variable is always on the left side. Variable must always be on the left side. So this is what each of our graphs is going to look like. If it has the equal to line underneath it, it's going to be a closed circle. If you are asked questions about what are some potential solutions, that's one of those kinds of questions that select all that would apply. So for here it says x is greater than -2. You're selecting all values that are greater or bigger than -2. -2 cannot be a part of that because it's not equal. It's not greater than or equal to. It's just greater than. So -2 and -3.4 are not part of the solution because those are all values that are either equal to it or less than the -2. The rest of these values happen to be greater than. When you are solving things that you need to make sure you keep in mind, you solve the exact same way that you would solve an equation. Get rid of the constant, then get rid of the coefficient or the divisor. So here we're adding 9 to both sides. Then we're going to divide both sides by a -6. Remember, if you divide or multiply by a negative, that causes you to flip the inequality symbol. Not the entire statement, just the symbol. So we would wind up getting x is greater than or equal to -9.2, or if you have it in decimal form, x is greater than or equal to -4.5. For problem number 4, you would be adding 5 to both sides and then dividing it by 8. That would come out to x is greater than 2. It would be an open circle at the 2 going to the right. Problem number 5, all you are doing is writing the inequality. You are not actually solving it at all. You're just writing it. So Len goes to the fair. She has $30 to spend. That means she can spend $30, but she can't spend any more than that, can she? $30 is the maximum she can spend. So if that's the maximum she can spend, that would be a less than or equal to 30. She spends $12.50 on food. That's a one-time purchase. She's also going to spend $1.50 for each ride. Each is going to signify that this is happening more than one time. That's a coefficient. Number of rides is unknown, so that's our variable. So here's our inequality. 1.50x plus the $12.50 for the food. It has to be less than or equal to 30. Okay, Billy has a goal to read at least 800 pages. At least is a greater than or equal to statement. So it's greater than or equal to 800. He's already read 85 pages, so that's our constant. He's going to read 20 pages every day. So there's our coefficient and variable. So 20d plus 85 is greater than or equal to 800. For problem 7, Betty is ordering goodie bags for her birthday party. Each goodie bag costs $5.50. There's your coefficient. Shipping charge is for the order is $10. That's your constant. You pay shipping one time. She is allowed to spend no more than $76. No more than means she can spend $76 or less than $76. So less than or equal to. So $5.50 x plus 10 is less than or equal to 75. Go ahead and flip to the next page. Problem number 8, which values listed are possible solutions for the following? You'd have to solve it first. You would subtract 6 from both sides. You get -4x is greater than 12. Then you divide both sides by -4, which causes you to flip the inequality because you are dividing by a negative. That becomes x is less than -3. So you're looking for all values that say that they are less than -3. So that would only be -4.5 and -6. Can't be -3 because -3 is actually equal to -3. So be mindful of that. You don't want to select -3 unless it has the equal to sign underneath. Okay, problem number 9. Josh has a $50 gift card to Starbucks. He plans to buy a coffee mug for $12, so he's buying that one time. He's also going to spend $2 on a cup of coffee each day. So that's your coefficient, 2 for each day. So maximum amount that he can spend on the cups of coffee, or maximum number of cups of coffee he can purchase without going over his gift card amount. So that gift card amount is the most that he can spend. That would be a less than or equal to 50. So 2x plus 12 is less than or equal to 50. 2x for the coffee each day, 12 for that one coffee mug, and it must stay under the gift card amount. Okay, solving again, subtract 11 from both sides, and then divide by a -3. Dividing by a negative causes us to flip the inequality, so we get x is less than 2. For problems 11, you are identifying what the compound inequality would be. So remember, compound inequalities are either an or an and statement. Okay, so for problem A, because they're going in opposite directions, that creates an or statement. So x is less than 5, because it's an open circle going to the left, or x is greater than 7. It's an open circle going to the right. For problem B, this is an and statement because it falls in between. It's a conjunction, right? So it starts at 5 and goes to 9, both of them open circles. So you could either write that 5 is less than x, which is less than 9, or you could write 9 is greater than x, which is greater than 5. Either one of those would be sufficient. For problem C, or statement, x is less than 5, or it is greater than or equal to 9. Problem number 9 is an and statement. 0 is less than or equal to x, which is less than to 3. Or you could write it as 3 is greater than x, which is greater than or equal to 0. Either one of those would be sufficient for problem D. Okay? For problem 12, you are subtracting 8 from all sides, not just from the single side or one side on the right or one side on the left. You're subtracting it from all 3 portions. So -12 minus 8, you're doing the 8 minus 8 and the 32 minus 8. That gives you -20 is less than 4x, which is less than or equal to 24. You would then divide each term by 4. So -20 divided by 4 is -5. Then you get your x in the center, and then 24 divided by 4 is 6. We did not need to flip any of the inequalities because we were dividing by a positive. Okay, since we're dividing by a positive, we keep the inequalities as it is. So there's our inequality statement. Problem number 13, it's an and statement. Okay, they didn't write it connected together like this and statement was. This is an and statement here. We've got x minus 7 is greater than -11. We're going to add 7 to both sides. Get x is greater than -4. Here we got 3x is less than or equal to 15, so we're going to divide both sides by 3 and get x is less than or equal to 5. So when we connect this together, if x is greater than -4, that would be an open circle starting at -4, and it continues to go to the right until we get to a +5, which is a closed circle, because a +5 closed circle goes to the left. So you're connecting them together. Okay, if we go to the next one. Number 14. You're just solving each of your separate inequalities and then graphing them. So here we would subtract 3 and then divide by 2, get x is less than -5. For the other statement, all we had to do is multiply by 3, get x is greater than or equal to 3, and then graph them. We have an open circle at -5 goes to the left, and a closed circle at +3 goes to the right. For problem 15, so I had you guys rewrite this instead. It should say 9 is greater than or equal to x, which is greater than 1. When you are graphing that, that means that you're going to start at a +1 open circle and go all the way to the 9 and end at the 9 with a closed circle. For problem number 16, when you're solving, all you're going to do is subtract the 2 from both sides. You get -7 is less than x, which is less than 4. So it's an open circle at -7 and an open circle at +4, and then you're connecting the 2 to come together for your and statement. Number 17, x is greater than or equal to 7 means it's a closed circle at 7, goes to the upper direction. x is less than 2 is an open circle at 2, goes in the lesser direction. For problem number 18, Jason has at most $100 to spend at Target. He plans to buy a jacket for, X, a shirt, which is Y, and sunglasses, which is Z. We're going to write an inequality to represent the situation. So he has at most, that's less than or equal to. He's going to buy all 3 items. We don't know what the price is for them, so we're just labeling them X plus Y plus Z, and it has to be less than or equal to 100. It's very, very simple. What? What's the question? You sure? Okay. For problem number 19, and here, the reason we don't have any coefficients is it tell us that we're buying more than one jacket, or more than one shirt, or more than one pair of sunglasses. It doesn't tell us any of that. It just says that we're buying a jacket, which signifies 1, a shirt, which signifies 1, and then sunglasses. It doesn't say 3 or 4 or 5, it just says sunglasses, okay? Number 19, solving the inequality. We're going to multiply both sides by -2. When we multiply by negative, it causes us to flip the inequality. Ooh, I didn't even show the flipping though. Huh. Fantastic. Let me fix that. I wrote that we needed to flip it and I didn't even do it. Okay. Is that one of the kids next door? Joseph. Fantastic. All right, number 20, we're going to divide both sides by 4. We're going to get x is greater than or equal to 3. And then here we're just identifying the common terminology and what it is linked to, what the inequality is. At least is a greater than or equal to. At most is less than or equal to. Less than is, a less than symbol. No more than is less than or equal to. If it exceeds, it's greater than. If it is above, it's greater than. If it is a minimum, it is greater than or equal to. Okay, so these are just a couple of statements for you to understand and know. All right, should be on the GIM kit.